grains on it, which would be closer to the other colors inside this picture. And so we can see that even though I did a good job on the quality, I screwed up on the color spectrum. Azawahiri is not the only person who appears in these Al-Qaeda videos. Another person is Azam al-Amriki, who's also known as Azam the American or Adam Gadam. That's, I think, his American name. According to this video from September 2006, he is sitting in a white room with a desk, a computer, and some books. But the question is, do the books really exist? The quality of the background of Azam al-Amriki, of the computer, and even of the desk is the same quality. He doesn't have a green screen halo going around him. In fact, the one part that does have an edge is actually monochrome. It's grayscale, so RG and B are all at the same quality. And the books, on the other hand, appear to be at the same quality as the subtitles and the As-Sahab logo. If we look at principal component analysis, the books really stand out. Just as Barney was in the wrong color spectrum, it appears that the books are in the wrong color spectrum. And if we just brighten up this picture, you can see these horizontal lines. The horizontal lines go through the background, they go through Azam al-Amriki, and they go through the computer, they go through the desk. This is because the original video source was an interlaced video source. And what we're seeing is the interlacing artifacts. However, the books and the As-Sahab logo do not have these horizontal lines going through them, suggesting that they came from a non-interlaced video source. If we actually graph the colors, RGB, onto the picture, there's two things that really stand out. The first is this cusp that comes up. Those are the gold colors from the As-Sahab logo and the subtitles. They are only found in the As-Sahab logo and the subtitles. They're not found anywhere else, so they're from the wrong color spectrum. The second is the blurry set of dots just below the main cluster. Those are the colors found in the books. The books do not match the same color cluster as the rest of the picture, again suggesting that they were added. So to wrap up this talk, there definitely is a need to show, to determine how real pictures, to distinguish real from computer-generated pictures. And if they've been modified, how were they modified? There are uses in media, such as determining reality from fiction, in legal circles for things like child pornography versus virtual child pornography, and even for authentication, telling real pictures from doctored pictures. I've covered a large number of methods for doing image analysis, and the whole idea is that a single picture may get a false result from one of these analysis or two of these analysis methods, but it's unlikely for a picture to be falsely classified by all of the methods. And these aren't even all the methods that are available. They're only the ones that I could cover in this time. I mean, there's lots of other methods out there, and this isn't even the whole list. Luminance gradient and signal to noise ratio are some of my favorites for determining whether a picture is real or fake. Are there any questions? Yes? Do any of these approaches help if an image has been resampled? It depends on how it was resampled. For example, media conversions, you can actually pick up some of the conversion artifacts. If a picture was resaved, you can pick up things like that. But as far as downgrading or upgrading the quality of it, sometimes, but it really depends on the algorithm. Yep. Yes? Approaches for analyzing video. I didn't talk about them in here, but one of the neat things about video is you can actually compare adjacent pictures. Because video for like an MPEG or, MP4 type video, something like that, or an AVI video, are actually stored at frames per second. And so we can actually go through those and compare them one next to the other and see if there's any modifications. Yes? I'm not aware of any book or journal that actually covers these. There's a couple of researchers. On your CD-ROM, I actually have a paper about this. There's a couple of researchers that are working in this area, and you might want to hunt down some of them. Yep. Oh. Right. the question was, how are these methods of detecting modifications done on camera? There's a lot of digital cameras, for example, that can do red eye reduction, that can do focusing, stuff like that, post-processing after you snap the picture. Red eye reduction really is easy to identify. It shows up like a sore thumb. Some of the others are not as easy because they do it in the RAW format before they convert it to JPEG. For identifying raw images or analyzing them, you're not going to look at things like the JPEG quality because, well, that doesn't exist. But you can look at color spectrum, use PCA on it. Principal component analysis will pull out stuff. Different types of light analysis will pull out information. If it was also converted from like a JPEG to RAW, you will still have the JPEG artifacts. The tools that I used, there's actually no tools publicly available that I know of. I actually built all of my own tools for doing this type of analysis. For principal component analysis and wavelets, I use the GNU Scientific Library. And I also use, the JPEG, the free JPEG library for loading in and saving JPEGs. Any other questions? Thank you all very much for your time.